This is Rosen, Discrete Mathematics and its Application. We start in section 13.1, talking about languages and grammars. And specifically, we will be talking about a type of formal language called a phrase structure grammar. And in the course of doing this, we will be dealing more with the context of syntax, not so much semantics. Syntax is form, semantics is meaning. The frog writes neatly is valid. Syntax, it's kind of silly phrase, but it's certainly a perfectly fine sentence for, syntactically. Swims quickly mathematics makes no sense either semantically and it does not obey proper English syntax. Natural languages are very complex, so we find that it's useful to study simplified languages called formal languages, although you'll notice that they're not necessarily that simple, but they're well structured, well defined. And we can apply rules and theories back to natural languages, but more to our interest to programming languages. All right, here's an example grammar, and we're going to start with the statement that a sentence is made up of a noun phrase and a verb phrase. What I'm going to be giving you is a bunch of rules that are used to generate syntactically correct sentences in my micro grammar here. What is a noun phrase? A noun phrase is an article followed by an adjective or a noun, or I can have a noun phrase that is just an article followed by a noun. Now I've got to produce some verb phrases. A verb phrase is the verb followed by an adverb, or it's just a verb. And then an article is a, or an article is the. And now we start to see non-bolded command structure. And you'll notice that these are what will be called terminal symbols. They never get replaced by anything. All the bold items are going to be replaced by something, but the italicized ones will not. Adjectives include large and hungry. Nouns include rabbit and mathematician. Verbs include eat and hops, and adverbs include quickly and wildly. And this is it for all the rules in my little example grammar here. And that's exactly what these are. These are called rules, or more appropriately, productions that form valid sentences when we keep replacing bold items eventually until no bold items remain. Here's an example. We start with sentence, replace it with noun phrase, verb phrase, replace noun phrase with article, adjective, noun, replace verb phrase with verb, adverb. Then we start to replace the non-terminal words with terminal words. And we get the large rabbit hops quickly, which is correct syntactically. We could create other sentences. The hungry mathematician eats wildly, large mathematician hops, the rabbit eats quickly, but we cannot produce something that looks like this. The quickly eats mathematician. We have no production that allows the adverb to come before the verb. So what we've just looked at is an example of a phrase structure grammar. Let's talk about some of the aspects of it. Phrase structure grammar has a vocabulary or an alphabet. And the elements in it are called symbols. In our example grammar, the alphabet was the words. The symbols were the words. A word or a sentence or a string over my alphabet is a string of finite length from the elements of my alphabet. So the sentences I was making are words in the previous example. We have the concept of the empty string or the null string given by lambda. That's the string containing no symbols or the string of zero length. Note that lambda is not a symbol of my vocabulary. I can't use it to make words. It is just represents the word that has 0 length. The set of all words over my vocabulary is called V star. That's the set of all possible strings. And then the language over V star, that's over V is a subset of V star. That's what the set of all possible words over my earlier grammar would have those nonsensical, non-syntactically correct um, sentences or words as elements, but those wouldn't be a language of my grammar. Since the word of 0 length is a possible word, it is always an element of V star, but whether or not it is an element of a given language depends on the rules. The elements of V that cannot be replaced are called terminals. Those are the italicized words on the previous grammar. Those that can be replaced are called non-terminals. Those were the bolded symbols in my last grammar. And then all of those 15 rules, those are called the productions of my grammar, and they have the form of one symbol or set of symbols replaced by another symbol or set of symbols. All right, well, what is a phrase structure grammar? It is a four-tuple. It has a vocabulary, a set of terminal symbols, a start symbol, and all the production rules. If we want to characterize the non-terminal symbols, we'll just subtract T from V. Productions must have one non-terminal symbol on the left side. It's like the bold elements, so the bold symbols from my last grammar. Here's an example grammar. Vocabulary is lowercase a and b, uppercase a and b, and s. Usually the non-terminal symbols will be capitals. The terminal symbols will be lowercase, and indeed we see that T contains a and b, the lowercase. We have a starting symbol. It's just S in this case, always going to be a member of your vocabulary. What was the starting symbol for my earlier example grammar? It was the word sentence. And my production rules. S produces the two non-terminal symbols A and B followed by A. A can produce BB, B can produce AB, and AB can produce B. And that is it for your introduction to phrase structure grammars.